Okay guys, this is going to be my second video talking about 4.3. We're going to talk about conditional probability. So conditional probability is if one event occurs after another. Okay, so probability of B, normally B is the second event, so B given A, B comes after A in the alphabet, B given A. Remember that the line straight down is a replacement for the word given. So B given A has already happened. Alright, so the equation for this is probability of A and B, so the and goes on top, over the probability of A. Now, how do you remember which one goes on the bottom? Well, if you look at this right here, it looks like B divided by A. Just remember that A is on the bottom, and that's the probability that goes on the bottom. Another way to think of this is that it's going to be probability of both over probability of the first, whichever one is the first to happen, or the given one. Alright, so if we look at this first example, let me scroll down. It says a box contains black chips and white chips. Person selects 2 chips without replacement. So that's important that they select 2 chips, because then we're going to have 2 things we're looking at. If the probability of selecting a black and white chip is 15 out of 56, so that is important right there. Black chip and a white chip is 15 out of 56, so black and white. And you can write this as a fraction, 15 out of 56 there. And then the next part says the probability of selecting a black chip on the first draw is 3 out of 8. Okay, so probability of a black first is 3 out of 8. Okay, so find the probability of selecting the white chip on the second draw. So probability of white chip given black chip. That's how you read it. White chip given black chip. So what that would look like is white given black. Okay, so if you look at up above where it says our equation, we're going to put the and on top. So that would be white and black on top. And then the last one, if you look at this as a fraction here, this will be white over black, which means black will be on the bottom. So probability of black. So now we'll just look at the different fractions that they gave us. So black and white goes on top. That would be 15 out of 56. And then we have on the bottom 3 out of 8. Now we can do this on our calculator if you have one. If not, then there's some algebra that you can do to get rid of these 2 different fractions here, because we don't really like fractions. We don't want them on top of each other for sure. So we can multiply by the reciprocal, which is just flip the fraction over. Y'all learned this in like Algebra 1, flip the baby, change the baby, keep the baby, something like that. So we flip the fraction, which is like multiplying by itself, on top and bottom, 8/3, 8/3. What this does is allows us to cancel out that bottom, and then we can multiply straight across or cross reduce. 8 goes into 56 7 times. 3 goes into 15 5 times. And so this comes out to be 5 sevenths. Beautiful, right? Now, if we don't want to do all of that algebra, then we can go over here and we can do 15 out of 56. Try that again. 15 out of 56 on top. And then we're going to divide by 3 out of 8 on bottom. And so it brings up 0.714. If we do math, enter, it's going to bring up that 5 sevenths, which is what we got. Okay, so either one of those. So 5/7 or approximately 0.714. Either one of those answers works. Now, example 2. Whoops. Going a little crazy there. Example 2. The probability that Sam parks in a no parking zone and gets a ticket is 0.06. So I'm going to write that down. What is this probability? The probability that he parks and gets a ticket. That's 0.06. The probability that he cannot find a legal parking space and has to park in a no parking zone is 0.20. So probability that he parks in a no parking zone is 0.20. Now, in order to get a ticket, you have to park the car first. So that has to come first. So what are we looking for? On Tuesday, Sam arrives at school and parks in a no parking zone. Find the probability that he will get a parking ticket. So this is how we would write it. I would not worry about how you write it as much as what it's asking. Ticket given. You don't really need to write the word given. I don't know why I did that. Ticket given that he parks in a no parking zone. Okay, so just remember that the and goes on top. That's this one here. So probability that he parks and gets a ticket goes on top, which would be 0.06 on top. Now, if you notice, which of these two here would be on the bottom was ticket over parks, which means that probability of parks would go on the bottom. That's just the other decimal that they gave us, so that would be 0.20. Alright, so then we would go back over here, 0.06 divided by 0.20, and we get 0.3, which is going to be also 3/10. Either way, that is going to be our answer for example 2. Okay, for example 3, a recent survey asked 100 people. It gives you all these totals here. I like this because a lot of times it doesn't give you the totals, but it does here for us. So that's nice. So for example A, it says the respondent answered yes given female. Okay, so yes given female. Probability of yes. Remember, this line is given and female. Now, anytime we have the given, you should know that the and goes on top. Seems we're having a bit of an issue. Okay, so hopefully we got the issues fixed. Okay, so yes given female. So remember, when we have the given problems, that you're going to put the and on top. So we're going to do yes and female on top. And then look at this as a fraction, yes over female, so female is going to go on the bottom. So what we're going to do is look at our chart up here. So yes and female, that would be 8. See that? Yes and female would be 8. I'm going to put that right here. And then we're going to do our total for female is 50. So 8 and 42 gave me 50. So that's going to go on the bottom. So 8 out of 50, which is 4 out of 25. And that's your answer there. Okay, so for the next one, it is respondent is male given no. Male given no. So we would write that. Male given no. Okay, so probability of both on top. So male, and no. And then on the bottom, out of these two, that will be no. Male over no. Okay, so male and no on top. Alright, no on the bottom. Okay, so then I go to my chart. Male and no. So here are the males. The males and the no's are right here. Male and no. That's 18. How many total no's do we have? Well, that would be 60. So 6 goes into both of those. That's 3/10 there. Alright, so that's the answer to that one. Alright, the last type of problem in 4.3 are at least one problems. Alright, so for at least one, anytime you see at least one, you need to follow this procedure. I'm going back to my old school stuff. Alright, so probability of at least one is 1 minus the probability of the opposite. Okay, so that's your equation there, if you need it. Alright, so the best way to learn this is just to do an example of it. So the example that's here is find the probability of at least one ace. Okay, so a game is played by drawing 4 cards out of a deck and replacing. So it's important that we know that we're replacing because the number on the bottom will always be the same when we replace them. Alright, so we're finding the probability of at least one ace. We're drawing 4 cards out, at least one ace. Okay, so it will be 1 minus the probability of not getting an ace. No aces. Alright, so let's talk about the probability of not getting an ace. Probability of not an ace, basically. If we're not getting an ace, there are 4 aces in a deck, which means there are 48 other cards in a deck of 52 that are not aces. So the probability of not getting an ace is 48 out of 52. We want to do this 4 times. So we want to not get an ace 4 times. So what this would look like is this. 1 minus the probability of not getting an ace is 48 out of 52, and we're going to do it 4 times, which is 48 out of 52 to the 4th power. Okay, so 48 out of 52 to the 4th power. So I'm going to do that. 48 out of 52. 48 out of 52. And then I'm going to raise that to the 4th power. Now remember, that's not our answer because I want to do 1 minus 0.726. And that would be close to our answer. So we're going to do 1 minus that, and we get 0.274. Okay, so that's how you do at least one problems. On the next one, it's very similar. You're going to do 1 minus the opposite on it as well. Okay, so if we look at this last example, it says a coin is tossed 5 times. What is the probability of getting at least one tail? Okay, so probability of at least one tail is 1 minus the opposite. Well, the opposite of getting a tail. Well, what's the opposite of getting a tail? Obviously, it's getting a head. So what's the probability of not getting a tail? Well, let's see. Well, what's the probability of getting a head? Well, the probability of getting a head on a coin is 1 out of 2. And how many times are we going to do that? Well, that's right here. It's 5 times. So I'm going to do that to the 5th power. Because this would be 1 minus, this would be 1 over 32, this would be 31 over 32. No, that's not right. Yeah, that's right. 31 out of 32, at least one tail. And on your calculator, this is how it looked like. 1 minus, and you could do the 1 divided by 2, and then you would raise that to the 5th. And it should come out to the same thing, we will see. So let's change that to a fraction. Math, enter. 31 out of 32. So that is your answer. Hopefully this helps. I will try and upload the 4.4 notes as soon as possible.